Hi, I'm Karen Shorey, working on behalf of VAT London. Explain a little bit about how people are going to get the QVA data, because having a kind of common approach to how this data will be distributed is quite important. So within our meetings, a while back, we agreed that the 9 different volcanic ash advisory centres would use a common approach for getting the QVA data to users. You know, for better experience, we don't want them all to be different. That just makes for more kind of programming headaches for people. So the key principles behind the systems that are being developed are that it must meet the ICAO requirement for system-wide information management. That's a kind of big one, and that anything meteorological and otherwise being developed for aviation is meant to meet that. We also agreed that we would use a common API framework, and that's something called the Open Geospatial Consortium Environmental Data Retrieval API Standard, which is a bit of a mouthful. And so even though there might be a few of the VACs that can't provide this right at the beginning, but it will be worked towards that everybody will move on to the same one eventually if they can't use it right at the very beginning. We also have agreed in terms of what data formats are going to be provided. So you would get like a different forecast, but data in the same format from each one. And data would be provided via each VAC's own API. This is one of the principles for system-wide information management, is that it's data direct from the producer to the user of the data. So you want VAT London data, you get it straight from VAT London. You want the Australian one, you go to them. And the 2 United States VACs will be merged into one, because they can you can share it if it's the same country. So within the actual API, you can think of it a bit like a kind of filing system for the data, and it will be organized into collections. And so there will be a collection that will contain the gridded deterministic data. So that's the one that will give you a value for each grid box. Oops. There'll be another collection that will contain the gridded probabilistic data for the 4 different concentration thresholds. And then another one for the polygon features as well. So they're kind of organized neatly. And then within each of those collections, you would publish data for whichever erupting volcanoes you had in your area of responsibility. So if there's one volcano, you just have data for one volcano, and it would be filed under its volcano number. If you had 6, apart from it being a really bad day, you would have 6 different ones listed. And we're defining them by the volcano number because some of them have really complicated names. And it's far easier just to give it a 6-digit ID. They've all got unique IDs. Now, volcanic eruptions are not regular. So one of the things that we don't want people doing is coming to our system every 5 minutes, 10 minutes saying, is there anything there yet? And pinging it to see if there's new data. So the systems will also come with a notification service. So it's like you subscribe to it, your computer can listen to it, and then it will ping a message that tells you when new data is published. So it gets rid of that burden. For things that are on a regular cycle, you can go back in every 6 hours, whatever, but this is not necessarily. And certainly from a VAT London point of view, we've been without an active eruption for quite some time, so we don't want this endless pinging of our system. So the VAT London QVA API is in development right now. It's probably going to be the first one that's available using this new standard that we've all agreed to use. And it will be swim compliant in accordance with the ICAO and also Eurocontrol requirements. And there are Eurocontrol requirements that set out the technical specification for something that's swim. And all these systems, they have to be listed in a swim registry when they're available, and ours will go in the Eurocontrol swim registry. And the API will be available for airlines, air navigation service providers, other organisations involved in the aviation industry and National Met Services to use. And we're expecting our system to become operational in early June 2025, or maybe the very end of May. So the notification system, it also has a set specification that goes with it. And will also have a heartbeat message so that you can make sure your system is connected to it, because there's no point you connecting to it. It drops the connection, then you don't find out until, you know, something's happened later on that you disconnected. I can't demonstrate that in real life, but if you look at the, hopefully you can see just about on the screen, a kind of example one in which it will just kind of listen in, and then all of a sudden it will just kind of appear and flash that there's new data. And so the data in that message that just appeared on the screen can be used to then automatically download from the main API to collect the data, because it will tell you what the volcano number is, and that's the controlling piece of information that you need. Within the API itself, there are kind of self-contained units. So the API contains metadata that gives information on the standards that it adheres to, information on the provider, help information, as well as information on the collections and what data it holds at any one time. So I'll just give you a demonstration in a moment. But the way it works is that you have access control. So you have a particular authentication so that you can get in. You have to be approved. And then you make a request to the system that would look something like this, with a web address. And then you would have information on your choice of collections. So there are a couple of options there. You would have a name of the specific collection. So we've got 3 different ones. And then the location ID would be the volcano number to specify it. So we actually have it hooked up already. And you don't need fancy technology, although most people, it will be your IT department will run it on a Linux server somewhere that do all of this. But I can do this from my laptop, for example. So you would have authentication is needed in order to get in. So I'm just going to make sure that mine's up to date. So you'd have to be approved. It's not a free-for-all that anybody can get in. And so I have the ability in here to find out information, say, about the collections it has available. So I'm going to see VA deterministic. I can spell. So I'm going to ask it, what data have you got for QVA deterministic in your database? It takes a moment. This is a bit slower than it would be in real life because this is through a VPN back to our headquarters. So it will return you a file with information about the data it has, various information about the system, and then it will tell you information like this. So it's telling me the temporal information for the data it has. Oops, it's got the start and the end time. I know it's a bit small, but I can't, it won't go larger, I'm afraid. It will tell me what time steps of data there is. It will tell me, move it out of the way. It will tell me what levels. And so they're in 5,000 foot slices. And we've actually just put the midpoint flight level value is what you can see along there. And then the important thing that I want to find out is what volcano have I got? This isn't real data, by the way, because nothing's erupting. Keep going down. I will find my volcano ID, 373050. So I can use that to find out and pull out a data set. So 373050. And I can ask it for data. And so it will take a moment, and then it will return me the gridded data set that you can then ingest into your own system and visualize it. I'll just let it run for a moment. Files are fairly large. Just to prove we actually have it working end to end. You can't read the format in like normal language. You get funny characters in it. So it looks a bit like this. And so what you can then do is take that data and visualize it up. And I've done it in advance really, because the software that I have available to me, you have to do a bit of tailoring to get it to display nicely. But you can integrate the data into whatever system it is that you're using. So if I start with the panel on the left-hand side, this is the deterministic. I've got multiple levels. So I'm going to go up a bit because there's a better chance of seeing some ash if I go up. And what I'm showing you is the ash concentration in, I should say, micrograms per cubic meter. So I've just run the scale up to 10, but if it's higher than 10, it's also in that same red color. And then I can time step through the different times to see where the ash is going. And I can go on up and down levels. So you might look at that one and go, okay, let's go down 5,000 feet or up 5,000 feet and see how it varies in the vertical. Now, what you could also do if you're ingesting it into a system, remember it's a 3D grid, you could take a slice through it, like a route through it, to see what it looks like in the vertical. Or you could do like a time series fixed point and how does it change over the time steps. It's the kind of things our forecasters do with other weather data. So there's lots of potential in the data there. I can't do it here. I don't have access to that kind of software on my laptop. And then you also have the probabilistic data that goes with it. So that's on the right-hand side here. And you would have access to not only the different levels, but the different thresholds. So you could compare side by side and look at different time steps. So this one, I've just selected the 0.2 milligrams per cubic meter. And so the red color indicates 100% probability or very close to 100%. And again, we can change the time, see where it's moving. We can go up or down, or we can go, actually, I'm not that worried about where it's greater than 0.2. I want to know where it's greater than 2. So let's go a higher threshold. Then it starts to help you focus in on where really is the highest concentrations of ash expected. If I go up one more on this to greater than 5, you can see it's really only close to the volcano in this situation. So you can use it in a different way on whatever system you've got, you know, integrate it into electronic flight bags or the flight planning system, whatever, and look at it in 3 dimensions. That's what it's intended for. So, and then the final thing, just to mention, is that there's also the QVA data set. If you were to download a QVA data set, we don't quite have that hooked up yet. The files look something like this, great long line of kind of parameters. It looks a bit like a web page, actually, if you understand those. With all the information for the polygons and a base and a top that you can then draw out into an image and plot them on a map. It's designed more for general situational awareness because the detail is in the gridded data. You could overlay that onto a map, onto other things. You know, you've got WAFs, significant weather charts with features and areas. You could put this as another layer on top of that if you wanted to. That's really what it's intended for. And of course, you can pick out the detailed. I've got a base and top on there. And you can animate it with time. I don't have my own viewer. I've just had to create an animation from Francis's nice images. So usable in different ways, the different types, but you can get them from the system. So early June, We plan to issue regular test and exercise data sets, because if nothing's erupting, you won't have anything to get set up on, which is a bit of a problem. So there'll be regular sets, and in due course, probably in January, February time, check back and look at that web page. We'll start to populate it with information on QVA data and then how to get onto the API when it's available.